Let's start with a very basic addition example. So what is the sum of 3 plus 2i and 5 plus 7i? You treat it just like you treat simple algebra. It's like 3 plus 2x and 5 plus 7x. Don't be intimidated by the term I. That's the key. So we have 3 plus 2i plus 5 plus 7i. So you add the real numbers, which is like 3 here and 5 here, and then imagine numbers 2i plus 7i. Very simple. And the answer will be 3 plus 5, 8 plus 7 plus 2, 9i. This is our answer. Multiplication works in exactly the same manner as well. Let's have a look at this example. What is the product of 3 plus 2i and 5 plus 7i? This is basically 3 plus 2x and 5 plus 7x. You multiply these, it's exactly the same thing. So let's do the multiplication. 3 plus 2i into 5 plus 7i. We have 3 into 5, 15, plus 3 into 7, 21i, plus 5 into 10, 10i, plus we have 7 into 2, 14i squared, because 7i into 2i is I squared. This is what you need to remember. Whenever you have an I square, you need to replace it with minus 1. That's the key. That's all you need to remember. So we have, let's do the math. 15 plus 21i plus 10i, this is basically 31i, plus 14 into minus 1. Replace I square with minus 1. That's the only differentiating factor. That's the thing that you need to remember. So we will be left with 15 minus 14 plus 31i. The answer is 1 plus 31i. This is the real component, this is the imaginary component, and this is our answer. Dividing complex numbers is a little different. These are the steps that we need to follow. Let's apply these on this example. Okay, the first step is, if necessary, write the division as a rational expression with the dividend in the numerator and the divisor in the denominator. Let's follow the steps. So, if a equals 4 minus 3i and b equals 2 plus I, what is a over b? This is what we are talking about. A is the dividend and b is the divisor. So, let's write this as a over b, which is 4 minus 3i over 2 plus I. This is what we are talking about in step number 1. Let's have a look at step number 2, which is the most important step. Multiply both the numerator and the denominator of the rational expression by the complex conjugate of the denominator. This is the key. This is the step that you need to follow, and that's it. So what's a complex conjugate? The complex conjugate of a complex number has the same real component and the opposite imaginary component. For example, the complex conjugate of 3 plus 2i is 3 minus 2i. See, the real component is the same, but we have the opposite imaginary component. Similarly, if you have 1 plus 2i, what's the complex conjugate of this? It will be 1 minus 2i. So you multiply this expression with the complex conjugate, which will be multiply by 2 minus I, you take the denominator, over 2 minus I. This is basically step number 2. Now the question is, why did we multiply this expression with the complex conjugate? Because we need to get rid of the I that is there in the denominator. And if we multiply I with another I, what do we get? We get I square, which is minus 1. This is the key. This is what we are basically doing. So after you multiply, you won't have an I in the denominator. And if you are a little intelligent, you will see that this is basically A plus B and this is basically A minus B. So A plus B into A minus B is what? This is A square minus B square. You see, we have the squared form over here. Now you just have to do the simple math. That's it. That's step 3, 4 and 5. Let's do the math and see what do we get. So 4 into 2 is 8. Then we have 4 into minus I is minus 4i. Then we have minus 6i plus 3i squared over, this is a squared minus b squared, which is basically 2 squared minus I squared. Okay, let's do the math. We have 8 minus 10i plus 3, replace I square with minus 1. That's the thing that you need to do. Please remember this. Over 4 minus, replace I square with minus 1. You see, now we don't have any I in the denominator. That was the plan. So the answer is 8 minus 10i plus 3. We have 5 minus 10i over 4 plus 1 is 5. You can simplify this as well. We will be left with, divide this entire expression by 5, 1 minus 2i. This is our answer. Let's understand the powers of I through this past paper question. If I equals under root minus 1, which of the following is equal to I raised to power 126? Whenever you have this kind of a question and you have any variable, all you need to do is write down some of the initial powers and understand the pattern, how the pattern moves by. You don't need to memorize this. I have already written some of the powers for you. All we need to do is evaluate this and then try to find out the pattern. So let's look at the powers first. What is I raised to power 1? Anything raised to power 1 is the number itself. What is I squared? We know it's minus 1. We have already talked about it multiple times. What is I raised to power 3? We can break it down into I squared into I. We have the same bases, powers add up and you will get the same number. Now, I squared is minus 1 and I will remain as it is and we will get minus I. So I cubed is basically minus I. Similarly, what is I raised to power 4? We can break it down into I square into I square, which is minus 1 into minus 1 and I square will give us 1. What is I raised to power 5? It is I raised to power 4 into I. Similarly, you see bases are same, powers add up. You can break it down into in any way you want. It will give you the same answer. I raised to power 4 is 1 into I will give us I. I raised to power 6 is basically I raised to power 4 into I squared. I raised to power 4 is 1 and I squared is minus 1. So 1 into minus 1 will give us minus 1. So we have 6 powers. We can identify a pattern. If you evaluate, if you analyze, the pattern basically finishes after the 4th power. And then there is repetition after that. There is no repetition before the 4th power. I raised to power 1 is I squared is minus 1, I cubed is minus I raised to power 4 is 1. I raised to power 5 is giving us I again, which is I raised to power 1. I raised to power 6 is giving us I squared. So I raised to power 7 will give us I raised to power 3. I raised to power 8 will give us I raised to power 4 and so on. So you see we have a pattern here. So if you have I raised to power 126, you can divide 126 by 4 and then count the remainder. So if you see, you get a whole number at 124. 124 divided by 4 will give you a whole number and the remainder is basically 2. What's the remainder? The remainder is basically 2. So 124 will be this value, 125 is this, 126 is this value. So our answer is basically minus 1. That's how you move through the values of I. Another way to look at it is through I square. You know, I square is our friend. It is our savior. So can I write I raised to power 126 as I squared whole raised to power 63? It's the same thing. You see, powers multiply. We know I squared is minus 1. Raised to the odd power will give us the same number. You see, we get minus 1 again. That is option choice B. Let's have a look at this question. If a plus b plus a minus bi equals 6 minus 4i, what is the value of a? Now we have an equation, and an equation is true only if the left hand side is equal to the right hand side. That's all you need to understand. So the real numbers, which are a plus b on the left hand side, should be equal to the real number on the right hand side, which is 6. And the imaginary numbers should be equal to the imaginary numbers. That's it. So we have a plus b on the left hand side. This should be equal to 6, which is on the right hand side. Similarly, the second equation should be a minus b equals minus 4. So similarly, if you have like ax square plus bx plus c equals 4x square minus 6x plus 3. If I ask you what is the value of a, you will say it is 4. You compare the coefficients. We are doing exactly the same thing here. So let's solve these equations. What do we get? Let's subtract them. We will have a plus a. We are basically adding the equations. We will have 2a equals 6 minus 4 is 2. A equals 1. This is our answer. There you go. Let's have a look at this question. Which of the following is equivalent to the complex numbers shown above? We've already talked about the powers of I. Let me write them down again. I raised to power 1 is I squared is minus 1, I raised to power cube is basically I squared into I, which is minus 1 into I, that is minus I raised to power 4 is I squared into I squared, which is minus 1 into minus 1, that is 1. And then powers repeat. So I raised to power 11, you just divide this by 4 and then count the remainder. So 11 divided by 4, we have 3 as a remainder. So 1, 2, 3. This is basically I raised to power 11. If there is no remainder, then you will have this answer. And then if there is like the remainder is 1, then you will have this answer. If it is 2, then this, 3, then this. Okay, this is I raised to power 11. This will be I raised to power 12 and this will be I raised to power 13. Okay, so I raised to power 11 is minus I, and then we have plus I. Minus I plus I is basically 0. So the answer is 0, which is option choice C.